my problems light, no more of hiding in silence.
Greetings everyone, I am Dusayan Faith Nueva together with my groupmates, and today we will present our workbook. Are you excited to know the application of mathematics to journalism? I got you! Later, I will share the application of mathematics in the field of mass communication.
Good day everyone, I am Vanessa E. Adamas. Later on, I will be discussing Fibonacci sequence and the golden ratio, which are the common patterns seen in nature. Are you ready to get mesmerized by its traces? So, just keep watching.
Good day to our viewers. I am Krishma Tabes. Statistics, like normal distribution, can be hard to understand, right? Don't worry, as I will be here to guide you in learning this topic.
Last but not the least, Miss Ann Tolentino. Later, she will give you insights about the planarity and Euler's formula as well as its examples. These are the common application of mathematics in the field of mass communication. Every day, we use math from the moment we wake up until the moment we go to bed. It's often said that math is the universal language. As we discovered more and more about nature, we found out that nature can be described mathematically. Mathematics plays a fundamental role in forecasting the weather. Numerical weather prediction uses mathematical models of the atmosphere and oceans to predict the weather based on current weather conditions. Mathematics is also an important concept in journalism. Journalism requires research into data and statistics. A good journalist needs to be able to understand and interpret numerical data, and this takes math proficiency. Journalist needs to be able to calculate percentages, ratios, rates of change, and other relationships between numbers. Application in media. Photographers use math to calculate a number of settings for their cameras, including shutter speed, aperture, and focal length. Math can be also applied to the composition of photograph using the rule of thirds.
First selected module for the mathematics in the modern world, here is the nature of mathematics discussing Fibonacci sequence and the golden ratio. Fibonacci sequence is a series of steadily increasing numbers. It follows the rule that each term in the sequence is equal to the sum of the preceding two numbers, while golden ratio is a mathematical ratio commonly found in nature. It exists when a line is divided into two parts, and the longer part is divided by the smaller part. When calculated, we can get the result of 1.618. Traces of this pattern that truly exists primarily in our lives and in nature. In music, the interval between keys in a piano is in Fibonacci numbers. In human body, the length of bones, specifically on our hands, tend to match the Fibonacci sequence. Did you know that even in our favorite fruits, Fibonacci sequence appears? Well, the banana has 3 to 5 flat sides that follows the number sequence. And in arts, the face of Mona Lisa has a ratio in its dimension of 1.618. Thus, golden ratio promotes compositions that are aesthetically pleasing to the eyes. To give you more ideas about the activities in our workbook, here are some of its examples. First, the activity about shells. We can use the Fibonacci numbers to draw a spiral with circles corresponding to each number. The width of the spiral from the center is 2.168, which is the golden ratio pi squared. And the activity about spiral galaxy is another example of Fibonacci sequence. It is simple because it has an average ratio of 1.618. Now, it's your turn to apply what you have learned throughout the lesson. Answer the question about the pineapple. Have fun, and thanks for being with me.
Greetings to our viewers! I will present the second selected module in our workbook, which is Module 10, Mathematics as a Statistical Tool. To be specific, normal distribution. To simplify this topic, normal distribution means that the data are symmetrically or equally distributed. Majority of the data points fall in the middle part and the rest spreads out on the left and right side. This is why you can see a bell curve or shape in graphs. Now let's learn how to solve a normal distribution problem about probability. First, subtract the mean from the x value. Second, divide the difference by the standard deviation. Third, compute the C-score. To do this, input all your values in the C-value formula and solve. Fourth, find the P-value. And last, divide 95% according to the area of interest or in order to shade the appropriate region. It's not too difficult, right? Now let's move on to our exercises. There are two difficulty levels here, easy and hard. I will show you some examples of our easy questions. For this, you only need to identify if the graph is an example of normal distribution. For example, this graph has a bell shape and most of the data are in the middle. This means that this is an example of normal distribution. Now, it's your turn to answer the questions. Don't forget to have fun and I wish you good luck.
To present or elaborate the last selected module in our workbook, it is about the mathematics of graph. In this topic, I will discuss about planarity and Euler's formula. So what is a planar graph? A planar graph in graph theory is a graph drawn on the plane, or it can be implanted in the plane where the edges intersect only at their endpoints. A planar graph is a specific type of graph that can be drawn so that no edges intersect each other. So now that we know about that, I will be showing you an easy example of a planar graph. Here in this graph, no two edges cross each other, so therefore, we can immediately say that it is indeed a planar graph. Using Euler's formula, if a connected planar graph has n vertices, m edges, and f faces, then n equals m plus f equals 2. So first, we have to let G be a connected planar simple graph with 25 vertices and 60 edges. In this problem, we have to find the number of regions in G. Let's say given that the number of vertices is 25 and number of edges is 60. By Euler's formula, we know that r equals 60 minus 25 plus 2 is equal to 37. Therefore, the total number of regions in this graph is 37. So it is really that simple. Next, let's move on to an exercise for all of you. In this picture, the question is it an example of a planar graph? The answer is yes, it is. As I mentioned earlier, in this graph, no edges cross each other. The edges intersect only at its endpoints, so then we can say it is a planar graph. Now that we know how this works, now it is your turn to answer this exercise. Good luck to your journey in this topic.